Excellent. So we're ready to get started. Is everyone here for the Building Amazon Cloud session? Because if you are, you're in the wrong place. All right, great. So why don't we go ahead and get started. My name is Alan Stewart. I'm a group program manager in the Windows Server and System Center group. As many of you know in Brad's keynote, we're one big happy family. Management, platform, together, a lot of love, all together. Right? So with me, I have...
I'm Philip Moss. I am a founding partner of NTTX. We are a UK-based service provider specializing in public and private cloud.
So why do we have two speakers? I'm going to ramble on about service provider architectures and principles and things that service providers have challenges with. And then you're going to talk to somebody who actually builds services for a living and operates a service for a living. So all the stuff that I say will be substantiated by Philip. If not, then you'll probably say, he doesn't know what he's talking about. He's not running a service. Where's the guys that are running the services? I want to talk to those guys. All right. So why do we have this session? So this was a session that I've been thinking about probably for the last 3 years, as I've engaged with service providers over the last 3 years and understanding service provider challenges. That was one of my roles within the product group. What are service providers doing? What sort of challenges they have building services? And I have this theory moving forward on what everybody's role is going to be moving forward in IT. Either you're building a service, operating a service, deploying a service, thinking about building an application for a service, or you're thinking about a service in some way. Everyone. Right? So why don't we talk about what are sort of challenges in building out services? Skills. There's a different set of skills that is required from an architect perspective. Like this is the architecture track. That's why this session is under architecture, right? So we're going to talk about some architect stuff. What are some of the challenges in building out a service? What are some of the things that you need to you consider when you're building out a service at scale, right? So we're going to talk through, what has been our focus in Windows Server and System Center. We've been focused on building out a shared multi-tenant service since Windows Server 2012 development. The scenario was the hosted cloud scenario. And this is one of the first time we took a look at an end-to-end scenario. How do we build out technology at the platform and management layer end-to-end to help you deliver a service? Now you may look at stuff, you may look at new features in the operating system and you say something like network virtualization. Like why is that there? It looks pretty cool. I can do live migration across data centers. The real requirement for network virtualization is in dealing with service providers. We found out that using VLANs and PVLANs was the way you did isolation for every customer. As you added customers, you added another VLAN. The more successful you were, the bigger headache you had managing VLANs and PVLANs in your environment, to the point where it's unscalable. We saw 8,000 VLANs, 7,000 VLANs, and that requires you to have new network gear. That requires you to manage those VLANs. So network virtualization was a response to solving that problem for building out a service, to flatten your network out and give you policy-based isolation. So we've been focusing in on service provider requirements, and I want to bring some of those things to bear. When you look at some of the features that we're talking about this week around R2, you may look at something like faster live migration. You're like, what the heck does that have to do with a service? It just sounds like something we should have. It's all about the service and how do you make the service better. So live migration with compression, RDMA, is about node evacuation and maintenance and operations in a service. That's why it exists. So I want to start with the service provider principles, and I'll talk about some features and areas in R2 and why they exist and how they exist under the service provider umbrella, and we'll talk through some of the challenges. We don't have enough time to get through all of them, so we're just going to really focus on compute, network, and storage, where everybody has to deal with compute, networking, and storage, and what are the challenges in building out a service. Okay? Good. All right. So like I mentioned before, from a Windows Server and System Center development perspective, we've been focused on building out a service since 2012 development. So all the feature set, particularly around the virtualization space, has been around how do we build out a service? How do we add and enhance the virtualization stack and the management stack all along this path of building out a shared multi-tenant service? Right? Everybody understand when I say a shared multi-tenant service, what I mean? Right? So from a service provider perspective, there's two types of services. There's a dedicated service where you just dedicated a bunch of compute to one single customer. And then you have what is called your public cloud resources, where you have multiple customers existing on a single instance of a hypervisor. You're running multiple VMs, unknown workloads, basic IaaS, DR, backup, right? Where there's no predictability. Customers bring basic IaaS VMs and they run whatever they want in it. And you, from a service provider, have zero visibility in what they run. You care a little bit. You care more that they pay you for the VM and they buy additional services from you. So we've been focused on building out a shared multi-tenant environment. So the other principle I have is everyone's a service provider. So some people are service providers and hosters, and that's what they do as a business, and they charge money for it. Even if you're in enterprise IT and you're building out a notion of a private cloud, you're a service provider as well. Are you hosting applications on behalf of a business unit? Are you running infrastructure on behalf of a business unit? Then you're a service provider. And a lot of in enterprise IT, they started to make this pivot to thinking, yeah, I am a service provider. But one thing that I found is there's some principles of being a service provider that everyone has to kind of follow if you're going to be along that service provider path. Right, I'll give you an example. Let's look at chargeback and billing. If you're in enterprise IT and you build out this rich public cloud, private cloud environment and you don't send out a bill for the month, what happens? You go out of business? No. Mere inconvenience. Your manager might get mad, upset. If you're a service provider and you don't send out a bill for the month, what happens? Somebody doesn't get paid, you go out of business, lose inventory, you lose credibility with your customers. So, there's a slight difference now just from things, some of the technical areas and what is really required. But if you look at the technology principles and architecture, they're very similar, right? Hosters don't have a concept of a showback. If you're running on infrastructure, you better be paying some money, right? So some of those principles are converging together. The other principles are around commodity hardware. When you look at enterprise IT and you look at some of the decisions you make around building out your private cloud environment, you may have very clear paths of the types of storage that you want to use, the types of servers that you want to use from your particular branded OEM, the types of switches you want to use. And if you look at some service providers today, their entire goal is focused on how much does it cost for me to deliver the VM. If the VM costs $150, how can I squeeze cost out of that? Am I making architectural decisions or buying decisions in hardware that cause that VM to be pretty high? They're really not wedded to any specific technology. They're wedded to their service and making it run more efficiently. Okay? So we're going to talk about some of those principles around commoditization of the hardware that you design. So when I say commoditization, we're talking about cheap components. How do we build stuff in the platform and management to take cheap components and make cheap components highly reliable and have that affect the bottom line, the cost of delivering your service? Okay? And if you look back at Windows Server 2012 and you look at 2012 R2, you look at the sets of services. I know we throw a bunch of services in the platform. You look at storage spaces, JBOD, SMB Direct, clusterware updating, 64 node clusters, network virtualization, live migration, storage migration, mobility, all these different things. All those features are about enhancing our shared IaaS architecture. How do we build a service? If you look at something like CAU, for example, clusterware updating, we gave you this great scalable cluster configuration in 2012 where you can scale to 64 node clusters. That's great. But you think about it when you're running a service and you have to do maintenance on a 64 node cluster. Right? You can do a lot of automation and write something yourself, I'm pretty sure. But with clusterware updating is a way in the box for us to interrogate nodes in the cluster, live migrate VMs from nodes, patch them, bring them back online until every node in the cluster has been updated. And that happens automatically. Right? So we couldn't give you this scalable cluster and say, this is great for service and scale, but yeah, it's probably a challenge in you updating and patching it. And then we also work with some of the hardware providers around CAU, and they wrote filter drivers that allow you to not only interrogate the node for the patches that are due for security, but also interrogate the hardware and give you firmware updates. So if we're going to do some maintenance in a service, why don't I use this opportunity to also do some maintenance on the hardware as well? Right? So it's simple things like that all go into making out a service. And if you look at storage was purely around, we talked to service providers, and what was the largest cost of delivering their service? It was around storage and managing very proprietary high-end storage. Right? The history of virtualization is technologies like live migration all brought along this shared storage, fiber channel, iSCSI requirement with it. And that brought a lot of, it's no secret that stuff is pretty significant cost in your environment. The storage is exploding and growing. So how do we take simple JBOD disks and allow you to build a highly reliable, highly redundant system out of cheaper disks? And that goes to the bottom line of your cost to deliver your service. So if you're spending $4 million on storage and now you can spend $1 million on storage, you pass that on. Now your cost of delivery is cheap. All right. How many people in the room are service providers? Good, we got a good bit. How many people in the room are coming from dedicated or enterprise IT? Okay, good. I'll ask this question. I like to ask this question in a session. How many people here know exactly the amount of cost it takes to deliver a VM in your environment? Yeah. That's generally where it gets to. So think about this. You're making decisions about what hardware to choose, and then you're passing that along into your service versus thinking about what target you want to hit and letting that drive some of your hardware architectural decisions. Okay? Okay. So now you know we're focused in Windows Server and System Center on building a shared multi-tenant IaaS environment. Whenever you see something around virtualization, I want you to think, hey, Alan told me this new feature in virtualization is about delivering a service, and I want you to think about how it fits into those principles of delivering a service, because everything will fit into that principle moving forward. Everything. Okay. So as a service provider, there's a few principles, right? So you're thinking about, how do I build out a shared multi-tenant infrastructure? Building a dedicated infrastructure is not very challenging. It's dedicated, right? You don't have a noisy neighbor problem. You have one customer running on some piece of kit, okay? That's where we're coming from. Moving forward, we're all in the service provider space. We're thinking about, how do you monetize a shared multi-tenant environment? So how do I build that out? What hardware do I choose? What decisions do I make? Do I have visibility into the applications that my user is running? Probably not. Not at all. How do I bill for it? How do I charge for it? What sort of infrastructure do I put in around a tenant experience? Automation. These are all the things that you start to think about, right? How do I build it out to scale? What scale do I start out? And then how do I handle what I call the best worst day in a service provider? The best day is a customer buys 2,000 VMs from you. The worst day is a customer bought 2,000 VMs from you. Because now what do you have to do? You look at your environment and you say, I wonder if this environment can handle 2,000 VMs, right? You ask the customer, what size? All sizes. I was afraid you were going to say that. Then you have to do some math. And I call it, on the next slide, I call it the capacity management jujitsu. There's one guy in an Excel spreadsheet. He goes away in a room. He comes back and says, 16 servers we need. And they're like, how do you know? They're like, I don't know. I just know we need 16 servers, right? That's hard to do some prediction in scaling out a service, right? You're building a shared business, and you have one guy doing some capacity planning jujitsu with Excel. And this is across 3 years of research. It's always one guy in an Excel spreadsheet. So I found that Excel is the biggest capacity planning tool in service providers, right? I was disappointed to find out. I was even hoping that there was some competitive tool that was there to say, okay, here's the target around doing capacity management. You know, we don't compete very well with Excel and Windows Server and System Center. Kind of hard, right? Right? The other thing is flexible hardware choices. So I talked about this move towards commoditization, right? If you look at the industry, anybody heard of open compute hardware? Heard of that notion? You know, that notion is about how do you drive costs out of hardware, period. Right? So I'm not making any news, right? That's saying cheap hardware is good. I'm not making any news. The industry is looking at how do they drive costs out of building out a service. Commodity means commodity, right? General, anything you could buy off the shelf components, but taking that and building a highly reliable 99.99% highly available service. Now, you talk to some people, that's kind of counterintuitive what you do today, right? You buy hardware that has 8 RAID controllers in it, multiple adapters, cache controllers, all these different kinds of technologies, right? And you pay for that privilege. Moving forward, the new design point in service providers is how do I move that away from that hardware and move that into software? Or how do I move into an environment where failure is accepted? How do I handle failure? So I'm going to design for failure. I'll give you an example. In Windows Azure, we don't use any shared storage. There's no shared storage. There's none. So you think, oh, okay, shared storage, how do you keep storage available, right? That's the service provider challenge. That, in a nutshell, in one area, just like storage, how do you make storage highly available, highly redundant in a massive cloud service without using super high-end components? Okay? So the other thing is, now that you have this shared environment, it's one thing to have a shared environment. It's another thing to say, I need to build services on top of the shared environment. Just because you can host a VM, you need to be able to offer services to your tenants, whether it be backup, DR, cloud storage, all these different services on top of it, right? So there's your basic IaaS, but go figure. A user may want to actually protect the workload they're running. They might actually want you to replicate the workload somewhere. So there's the base, and then there's services on top of it. And why am I talking about services? Because we've moved into not only building out the shared multi-tenant environment, but starting to add services on top of the platform, like Hyper-V Replica. Right? It's no secret that Hyper-V Replica is something that, while it delivers DR, you as a service provider, and there's a few service providers that we work with, use that to add as a menu of services for your users. You want additional DR? We can give it to you. Absolutely. Additional $10 in the VM. So how do you take that VM and make it very compelling and available? And the last thing that I want to talk about, automation is assumed in service providers. Right? You're going to build out a service, predictable tasks, automation is assumed. It's not even accepted to not have some high level of automation around tasks or even delivering services to your tenants from a gallery where they can go select the service and have the service built out. You're moving into the space now where the service is something like SharePoint, where users are able to go to your portal and say, I want a 1,500 user SharePoint environment. And logic that exists in your CMDB says 1,500 means 4 front-end servers, 2 index servers, and a SQL cluster, and having that automatically built out on your infrastructure. Right? Okay. One other thing, interop is assumed. As a service provider, you don't dictate what workloads your customers run. They dictate what they run. So if a customer comes to you and says, hey, I want to run 3,000 Linux instances, you can promptly shake their hand and send them to your competitor. Or you can tell your internal business unit, that's an interesting app you've designed, but we don't support you. And how long would you be around in that instance? Not too long, right? So interop is assumed, and I'm going to talk a little bit about some of the stuff that we're doing around interop and parity between Windows and Linux guests. That's assumed, right? And live site operations just means we're starting to look at the service. How do we operate the service as a live site? This is a live site. So things like mobility, maintenance, these things can affect the site and availability, uptime, and potentially have you giving back money to customers. So that puts pressure on us, too, when you think about upgrading, maintenance, and patching. Our mentality has to be that you're running this service, how do we provide you the capabilities of doing software updates in a live service? That's why you see things like CAU also driving some of our thinking. Okay, so let's get into a few of the areas, right? I'm going to touch on a few of them. Not all of the problems, but some problems that are really, when you see them, you'll say, yeah, that's a problem in a shared multi-tenant environment. So on the compute side, what are some of the challenges? One, how much compute do I need and how much do I buy? You want to be in a just-in-time fashion, right? You want to be just-in-time, but you don't want to be just-in-time. You want to be just-in-time from an architect's perspective, because as I need capacity, I can add it on. Remember, the tooling that you have today is one guy in the back of the room with an Excel spreadsheet. Not too dynamic, right? The other challenges you have is inventory. Do you scale out your service and add more servers to the service so you can protect yourself? Of course you do. When you do that, is that hardware that you're not able to monetize initially? Absolutely. Is that hardware taking power and cooling and sitting around and waiting for you to sell customers on using it? Absolutely. So you want to get somewhere closer to running high. You want to run your service at 90% effective utilization, but you want to have some flexibility in being able to have, capacity for that best worst day that I talked about, right? And then we talked about the jujitsu, right? There's no real good tools that do what is called what-if modeling. So what if I sold 2,000 VMs tomorrow? What does my environment need if I had to do that? Just a simple model and capacity model, right? That would drive forward, and that would actually put the Excel guy, you can put him to work doing something else if you had tools like that, right? And how do we do noisy neighbor management? Everybody knows what noisy neighbor is? You're in a shared multi-tenant environment. Your workload and my workload are neighbors. They become intimate. If I'm very busy from an IOP perspective, and you're busy from an IOP perspective, we can starve each other out to the point where we're both calling you saying, why is your service so slow? I can't use it, right? Because you have two workloads that are colluding and colliding on each other at the compute level, the storage level, and the network level. These are things that you have to actually manage, right? And if we're going to help you build out a shared multi-tenant service, we have to manage it and give you tools to be able to manage it. Okay? So we talked about just-in-time compute. The other thing is you have no visibility in what applications are running on this service. Zero. So what applications do you need to prepare for? All. You're like, well, how do I design for all? Meaning high-end SQL IOPS. So you better have a high-end IOPS service that's based on SSDs. Lower-end workloads that are network intensive. Your infrastructure should be able to handle network-intensive applications. It should be able to handle CPU-intensive applications. And you have to think about this when you're architecting the service out. Because unless you're going to go into business, think about it. You're an enterprise IT, you build out this shared multi-tenant environment and says, we're good for probably about 80% of the workloads. The other 20% we can't handle. That probably wouldn't go over well with your boss. Okay? Okay. So let's look at a few different technologies in R2 and how do they help you from a compute perspective? So let's look at in-place virtual machine machine migration. So the ability to live migrate virtual machines from 2012 to R2. Now you're a service provider. You bought off on our message to build out 64 node clusters. You're on 2012. I come along with R2. Much more features for you. Helps you build out your environment. How do I move? You don't. Or you build a new one and you take downtime. You remember that principle that I said before for a service provider is live site operations? This is a live site. So you go to your users. Basically, I'm asking you to go to your users and say, Microsoft, Alan really convinced me that their new platform will help me run my service. But to do it, on the weekend, I'm going to have to take your VM down. What do you think? Right? It's not going to fly. So technologies like the ability now for you to be able to do a live migration from an R2 for a 2012 cluster to an R2 cluster helps you from an outage perspective. There is no outage. It's live site. And if you've come from the clustering from 2012, from 2008 R2 to 2012, everybody knew that was a downtime action. One, you had to evict nodes, have more hardware. We gave you a wizard, but the VMs were offline. And that's just not acceptable from a service provider perspective. Okay? So what does it give you from a service provider perspective? Flexibility in adding additional compute capacity and taking no downtime in moving workloads. Between platforms, this is a whole platform shift. So it's not like you're doing maintenance. This is an entire platform shift. So faster live migration, how does this apply? So we got, you can do fast live migration with compression. Compression uses some more CPU cycles, but it effectively gives you a faster performing live migration. And then if you use RDMA, where you're offloading those CPU interrupts and compute cycles onto the network cards, right, it's even faster. How many people saw Jeff Woolsey's keynote demo and you saw the difference, right? 7 seconds for live migrating virtual machines off a host. Now that looked like a really cool demo. What's the practical way you would use that as a service provider? Node evacuation, maintenance. 7 seconds versus 45 seconds, the ability for you to completely drain a node of all the virtual machines because you want to do some maintenance on the host. A drive failed, some issue with the service. Okay? Some flexibility, performance. That feature ties back into a service level and it gives you some enhancements. Now this is a good one from a service provider perspective. How many people just wanted to resize their VM? So customer says, my VM's too small, can I grow? I want to grow it. I want additional capacity. They're asking you to pay for additional storage capacity. In the past, what was that action? Was that a live action? No. At best, you could add another VHD to the machine and go through some hocus pocus. Now, it's just a mere activity. So you could literally have a task in your service called add additional storage. And you could say, you want additional storage? How much? Okay, I just added it. Done. Okay? All back into the service. Customer needs immediate capacity. Add it with no downtime. You see a theme around downtime in service? Downtime equals bad, bad, bad. No downtime, right? We don't want any downtime. So virtual machine export and clone. Customer just wants to take a backup. You want to offer a rich backup service without having to take down the virtual machine. You want to clone it, snap it. They want a copy of it. All kinds of things that customers would want with their virtual machine and their data. Okay, so it gives you some flexibility. Maybe it's additional backup. Maybe you're snapping it, dumping it off the cheap storage, and you have a process that runs and picks it up. That's all stuff that you can monetize in your environment. And when you hear me say monetize, right, it may be slanted from a service provider perspective. If you're an enterprise, it's not just monetization, it's user satisfaction. Right? Your developers are probably a little resistance in building out this infrastructure where all their servers are going to go away. They can't see their server, it runs in your service, and they're depending on you to run and provide high orders of availability. The ability to have this kind of additional service gives them trust in the service. We take a snapshot of your VM 4 times a day, it's always protected. Wow. We replicate it 4 times a day. Right? Gives the trust in the service. Okay, storage quas. So noisy neighbor. Noisy neighbor at the CPU level, noisy neighbor at the network level. So we had network quas. In 2012 R2, we added in the concept of network quas down to the VM level. And we heard lots of feedback from you to say, that was great. What about this storage thing? And we said, yeah, you're right. That's on the table. So in 2012 R2, we added the concept of being able to do storage quas. So now you can protect on your shared multi-tenant environment workloads from killing other workloads because they have high IOP usage during an individual time or period. Okay? So it prevents a tenant or an app from just taking over and saying, I'm going to use all the IOPS on the environment and starving the other VMs. All part of running the service. Okay, my favorite topic. Why? Because I have a rich Unix, Linux history, is interop. You are now running workloads. You built this service. People are going to come and use your service, and they're going to bring lots of stuff to your service. They're going to bring Microsoft applications. They're going to bring Microsoft OSs. They're going to bring non-Microsoft, middleware, all these components. So one of the things that we've taken as a principle is Windows and Linux guests should have parity and perform at parity. Right? Now that's news, right? That should be news. We've taken, if we're going to build a service environment, we need to ensure that the things that you run on your service are at parity. So in 2012, we had 64 virtual CPUs in Windows guests, live snapshotting, dynamic memory, the list goes on. And when you ask me, what about Linux? 8 CPUs, no online snapshotting, no dynamic memory, and you started to feel like, well, that's pretty handicapping, right? Your customers expect more from that. So we took the principle to say, even if we have to develop components that we check into the Linux branch ourselves to ensure parity, that's something that we were going to do. In 2012, Microsoft was the top 10 check-ins in the Linux kernel branch. We were in the top 10. So moving forward in R2, here's some additional enhancements we added in. We've added in the concept of dynamic memory. So now memory can balloon and shrink. Gives you some flexibility from managing memory in your shared environment. The other thing we added in was Linux didn't have this concept of VSS. We had VSS in the platform. We were able to take live online snapshots using a combination of writers that had application level awareness. So the AD writer, Exchange writer, Oracle even had a writer. So we could QS the workload and take an application consistent snapshot. And we weren't able to do that with Linux because obviously there was no VSS infrastructure. So using some of the common Linux tools, we added in the concept of being able to do live volume snapshots in R2 of Linux instances. So you get an OS consistent snapshot. The other thing that we added in was online resizing. So this other capability that we had, online resizing, because obviously there's a different device management between Windows and Linux, but now online resizing of VHDs is a part of the platform. And then we also enhanced the synthetic 2D video driver, buffer frame driver, which, starting to get you down the path of improved display performance. Not saying that everybody has needs around OpenGL or huge display instances on Linux distros, but gives you a better sort of display environment from the old video environment that we had before. And that's taking advantage of some of the Gen 2 VM work that we're doing in R2 as well. So Linux instances will be first-class citizens on the platform. And we'll work to check in code to ensure it. Okay? And if you want news, there's the news. So Linux distros will enjoy the same performance scalability as Windows instances. Okay, something else that I want to bring up from a service provider perspective. These customers bring these crazy workloads to you and they say, I'm running an application and now I want to cluster the application. What was the mechanism that you had to cluster it before? iSCSI or Fiber Channel? That goes completely away from where we're trying to go with scale-out file servers, SMB, flexible storage options, to force you back to the old paradigm where we're trying to force your architecture away from to just to do something like provide highly available clustered applications to your users is weird and is something that we didn't want to do. So with shared VHDX, now you have the capability of being able to have a shared VHD file that you can use to cluster two virtual machines. So if you're running SQL Server, you can use a shared VHDX, so there's no dependency when you go to cluster, which cluster requires shared storage, there's no dependency on iSCSI or Fiber Channel moving forward. So you can completely have an SMB-based storage spaces, SMB direct-based environment for your tenants and for your base infrastructure. Okay? So again, more flexibility in running your service. And this is something that you can provide to your tenants. This is a service that you can provide to your tenants. Right? Additional protection, additional clustering, right? And capability. Okay. So, disaster recovery. So what do we do around this space? So disaster recovery is not really important in a shared multi-tenant environment, right? Who cares about disaster recovery? Right? Data center fails, service is out, you're pretty much out of business anyway, right? Of course they care, right? So what do we do? So if you start to think, remember I said this paradigm shift in 2012 where we're starting to look at service provider requirements. So from 2012, we added a DR platform. Hyper-V Replica came into existence. We had a bunch of service providers and enterprises that we put together to say, hey, could I replicate using Hyper-V Replica from my enterprise data center to a service provider? We ran a program called Project OnRamp that connected people at early adopter stage, and they were doing that, at early adopter stage. So proving out that was fine. Moving forward, now we wanted to think about what were some of the things that we can use to enhance the platform around DR. And what did we hear? We heard 15 minutes, not good enough. We heard synchronous. We want synchronous. We want synchronous-based replication. 15 minutes is not good enough for mission-critical workloads. Thanks, but no thanks. How can you make it more flexible? And then we want management at scale. We want to be able to manage this at scale now. We want to deliver this as a service. We want more services principles enabled into it. So what do? So we had some principles for it. Look, DR is complicated enough. We don't want to make it any more complicated, right? We wanted to have something simple, which was over-the-wire based DR, the ability for you to choose at a granular level what VMs you wanted to have replicated, right? So think about it. Some VMs require replication, some don't. In the enterprise, it's true. Some are more applications are more mission critical. As a service provider, some people are going to pay for it, some people are not. So now you have the capability of being able to do it at a granular level. Now we needed to be able to scale it out and make it more extensible as well. So one of the first things we did is now you have the concept of tertiary replication. So, point A to point B was not good enough. We wanted to have point A to point B to point C, right? Just in case you had this cascading data center failure, right? The other thing, we offered now the capability to be able to configure the replication from 15 minutes to 5 minutes to 30 seconds. 30 seconds is near synchronous. Now I hear you in the room. I hear it loud and clear. I said synchronous, right? Near synchronous, and what do you think we're going to wind up doing eventually, right? We're going to eventually make it a more synchronous action, right? We're getting there. When you're at near synchronous on a technology that doesn't require you to have any physical hardware to build out, it's a good capability at that point, right? All right. Storage. Favorite topic, right? How many people here think they've nailed the storage architecture completely in your shared multi-tenant environment? Just nailed it. It's not a problem. It costs cheap, it's highly available, it's effective, it's performant. Everybody? Good. Yes. I think we're along that journey, right? So what were some of the specific challenges from a service provider perspective in storage? You need to deliver IOPS. Remember I told you, you don't know what's running in the VM. Everything's running there, right? Data warehouses, you name it, is running there. So you need the capability to be able to build out so you can deliver IaaS. But you shared IaaS environment, but you also don't want to break your pocket in the process of doing it, right? Multi-tenant aware storage. Now you have tenants that are aware. How do tenants get storage? What if a tenant needs a file server or needs some sort of SAN. How do you provide that capability, right? They may have an application that requires high orders of storage. And of course, we talked about the noisy neighbor problem. You need to manage the IOPS in the environment. How do you control and constrain and allow to grow and shrink so you don't run into the issues of one application affecting others? And you want to be able to leverage this without having to spend millions of dollars to build it out. There are lots of solutions that will help you down this path. They're just very expensive solutions. And if we are architects focusing on the cost of delivery of the service, if you buy $6 million worth of hardware, that goes into the bottom line for delivering your service. And whether you are a hosting provider or an enterprise, if you're an enterprise, eventually you have to look at your cost of delivery versus other entities. What's the cost of my VM? My VM costs $150. Somebody else is able to deliver a VM at $5. Okay? Once that starts getting into the the suit kind of guys, all they see is $150, $5. What's wrong in this picture? Right? What are we doing? Right? Different. So the ability to have flexible hardware choices, particularly running around JBOD, but making it highly available is something that we've taken on as a challenge in conjunction with the service provider problem. Okay? And the other thing is now that, okay, so Microsoft, we convinced in this file-based stuff, SMB, JBODs, okay, how do I manage this stuff? So let's say I'm convinced with SMB Direct, we got in storage spaces, I've got extreme performance, and you could meet the need of any workload. Now, how do I manage this stuff? Because before I had all these different tools that gave me some visibility or showed me a bunch of knobs, what do you have to manage this stuff? Right? Right, so these are our storage objectives. Minimum, make it highly available, minimize the operating costs, and minimize the CapEx. So managing it, buying it, minimizing the cost, but all while making it highly available and maximizing IOPS. Doesn't that sound like the kitchen sink? That's the kitchen sink. Make it cheap, don't require me to have more people, make it fast, and make it highly available. Right? So what is our architecture? I'm just going to skip to the chase. Let's talk about it. What are we proposing? With scale-out file clusters, how many people here have had experience with scale-out file clusters in 2012? Good. So not many people have started to look at storage spaces and JBODs. How many people here have experience deploying storage spaces? Okay. How many people know what storage spaces is? Okay, it's good. It's good. You know what it is, but you're like, okay, I don't know where this exactly fits. So if you look at this environment, so think about this is storage for your shared multi-tenant backend. You built this service, and now you're building out storage. So you got your Hyper-V compute nodes. You have things called SMB Direct. SMB Direct is RDMA, right? InfiniBand, RDMA over Ethernet, right? This was technology that I used about 13 years ago when I was on Wall Street building banking apps. This was what we used between compute nodes to deliver low latency and low interrupt overhead. Allowed us to be able to experience the theoretical limits of the hardware, and we don't have big round trip times. We're using that technology to deliver remote-based storage now. And you don't have a dependency on InfiniBand where you had to have specialized switches. Now you have RDMA over Ethernet. So now you can run RDMA over 10 gig Ethernet adapters. Right? Where an InfiniBand adapter 12 years ago was $2,500 per machine plus the switches. Now this is just basic Intel NetEffect, Mellanox-based devices, $300 or $400 network adapters that you can run this stuff over now. Okay? So then you have scale-out file clusters, 4 compute nodes, connected via SAS to just JBOD-based disk, shared SAS to JBOD-based disk. So think of the commoditization in that stack. This is your SAN, right? This is your SAN environment. And using storage spaces to provide you pooling and tiering and mirroring and protection, because in this instance, you're taking out that RAID controller that you had before, that SAN adapter, that where if you talk to any SAN vendors, we have the 64 1 terabyte memory in the controller that caches everything and delivers super performance. Remember that thing? Right? So in this storage spaces is performing that intelligent action for protection and making your storage pools highly available, allowing you to configure pools, making it highly available as well. Right? So this is the environment now that you can deliver highly performant storage over by taking the dependency just on commodity-based components, compute nodes, software like storage spaces around pooling and protection, and scale-out file clusters. Okay. So tiered storage is something we added in 2012. This is the concept of being able to tier your storage. Where you could say, in this previous configuration, some of the disks may be SSDs, and some of them may be just typical spinning media, and allowing you to actually tier out the different classes of service. So think about it in your shared multi-tenant environment where I told you you can't predict what workloads are coming into your environment. You can have a set of storage that's SSDs for workloads that have high IOP-based demands. And for workloads where there's not such high IOP-based demands, you can just use regular spinning media. So there's flexibility there. And then I'm going to show you another slide where you can combine that with Virtual Machine Manager. So when you configure a service in your cloud, you can set a tier of service. So let's just say you're deploying SQL Server. SQL Server, there's a service in your gallery called Deploy High IOP SQL Service. When that's actually deployed, those SQL instances will automatically be routed to a pool of SSD storage that are classified for high IOPS. Or if not, they can be routed directly to just regular spinning media. So from a service perspective, it gives you extreme flexibility in deciding how do you want to service different types of workloads. Remember, service. This all ties back into delivering that service. All right. Remember I said management. How do I manage this stuff? So let's just say I bought Office fast, it's performant, I get it. You fight the storage management battle or with your storage architects that are, they're in love with Fibre Channel or in love with iSCSI. You fought the battle, you won. Probably took you a little bit to fight that battle. You probably have battle scars, but you won. All right? Now it's like, all right, but none of this stuff can be managed. How can I manage this stuff? So we were focused on being able to manage, about providing insight into how the pool is performing, flexibility in provisioning, and automation, PowerShell, but also tying that back to the multi-tenant environment too, with VMM and VMM being able to classify. When it builds out the fabric, you being able to build out the fabric from their VMM console and then classify storage to it. So the first thing is, the boring part of it is, guess what? In the storage management space, there is 80,000 APIs to manage storage. Every vendor has an API. There's their tools, because they're all attempting to manage the data center at one point, right? Your storage vendor wanted to be your management vendor for the data center. Go figure. Everybody wanted to grow up to be the console in the data center. So now at SMIS, we have a single interface provided. The OEMs write SMIS adapters and all along this path, a single interface that you can use to do provisioning. Now, why is this important? If you're building out a shared multi-tenant service, you can't have 80 different APIs to do different work. Now you can kind of standardize on a single management component that allows you to provision the different storage entities, whether it be NAS, JBODs, Fibre Channel, iSCSI. So this single interface allows you to be very flexible. That's where it starts, right? Now you have to have a single API to be able to do management. And now when you look at, from a scale-out file cluster, which I said is your basis for a shared multi-tenant environment in Windows and Windows Server, VMM plus scale-out and your storage options, now you can use Virtual Machine Manager when you're provisioning your fabric for your service to do allocation and build out your scale-out file cluster environment and allocate storage to tiers. Now this is when your flexibility comes in. So now you add the management overlay on top of it, and now you get provisioning, you get classification, and you get provisioning of your services from templates directly to a class of storage. So you're building out that fabric. Right? So if you look at, this is something that VMM offers you, the capability of being able to classify storage as gold or silver, and that, like I said, that could just be high IOPS, low IOPS. So when you provision a service, you can have it routed directly appropriately, depending on the requirement from an IOP perspective. So, gold, silver is just a way to actually different classifications at the pool level, at the volume level. So when you provision in the fabric, the service can go and be routed automatically in the actual service template directly to the class of storage. So once you provision the fabric, you don't need to do anything after that. You can have sets of services that automatically route and provision on the type of storage that you want. And then giving you placement, movement, where you can actually now move somebody from a class of service. How many times are you going to have a user that says, do you need high IOPS? Why? Are you going to charge me for it? Yes. No, I don't need high IOPS. Low IOPS seems pretty good. A month later, they're like, my application is running pretty poorly. Yeah, we noticed that you're running about 1,000 IOPS over what you said you allocated. So we're going to move you into the gold storage class. because you require it. I can show you that you require it, and that means extra money, but you really need it. So giving you that capability of being able to dynamically move and classify workloads and move them between storage pools. Okay? All flexibility. All right, last but not least, we'll just touch on networking, one area of networking. Networking, you could spend another 8 hours on, right? Software-defined, not software-defined, PV LANs, multi-tenant gateways. We're just going to focus on one problem. All right, so on the network side of it, how do I make this promise of network virtualization real? So I talked about the problem that we were solving with network virtualization was to get it you out of the PV LAN game and VLAN. Flatten your network. Make it flat. Provide red-green networks and networks that are isolated from each other in a policy-based fashion. The VM moves around your environment. The policy travels with the VM. So if you said the Coke VM never talks to the Pepsi VM, you can migrate it all around your environment, and they will never talk. And you don't have to have VLANs to do any of that. It's like the panacea, right? What? No VLANs? I can flatten my network? Right? So how do we make that real? There were some requirements initially in 2012 around having a hardware-based NVGRE gateway, and that took some dependency on hardware. Right? You had to have a hardware vendor, had a gateway available, and there were some delays in getting gateways out into the industry. So what do? In 2012 R2, we added in a software-based NVGRE gateway. So now we truly don't take any dependency on the physical network environment. We have a software-based NVGRE gateway in the box in 2012 R2. Right? The other thing is, if you're providing site-to-site VPN or capability as a service provider, every tenant had to have their own VPN server. Because we didn't have a multi-tenant VPN client or device or server, which meant there was a one-to-one connection. There wasn't this one box that had the concept of you're a tenant, you're a tenant, you're a tenant. I'm going to route and keep separate pipelines separate from each other. That cost you to have additional networking gear. You build out the service and you got a device for every user. Right? That just didn't scale from a multi-tenant perspective. And then all this dynamic provisioning of workloads, you hear about this SDN stuff. What's software-defined networking? The network dynamically routing and picking out where it should go, VLANs being created, isolation. How does all that stuff kind of fit together and work? So if you look at one thing that we did in 2012 in the hybrid cloud space, we added the concept of network virtualization. So remember, we wanted to solve that PV LAN or VLAN problem. So we added the concept of network virtualization, virtualize your network, provide you policy-based isolation. So if you look, we have your red, your blue, your green networks, and all those are separate from each other. Each VM acts as if they're isolated in a little network amongst themselves. They never see each other unless you specifically say they're able to route and talk. Right? So it's not security by obscurity, it's real security at the network level. But it also, some of the other benefits is you can live migrate VMs around your environment if you're using network virtualization without changing the IP classification of the VM at all. So 10.1.1 in the green network and red network, you'd have same VLAN, same IP address. They can route around the environment because of the magic of network virtualization. Now, one thing that we require from the gateway perspective is when you had to have a site-to-site VPN, we required you to have a site-to-site VPN server for each network. So if you did isolation, which you wanted to, so we got you out of VLANs, you provided network classifications where you wanted to have VMs only talk to each other, but then the downside of that is every one of them, because they weren't talking, now you had to have a VPN server per tenant network. And how many tenant networks did you have? 7,000 maybe? 5,000? That's probably unsustainable, particularly if we're into the cost of the service. Right? You made some VPN vendor pretty happy here. Even Microsoft you made pretty happy. That's a server everywhere there, right? So what do we do in 2012 R2? And we built a concept of a multi-tenant gateway. A single gateway can now have different tunnels into different networks, into different clients. So you have an enterprise network where you're doing this hybrid connectivity, right? This is all around hybrid. How do you extend your network from an enterprise into a service provider or a service provider back into an enterprise? So single device. We need to have, if we're going to have a single device doing multi-tenant, you need to have the capability of clustering these devices. So one goes down, you need the capability of the site-to-site VPN to continue to exist. Why? Because on the enterprise side, your network may be extended into a cloud provider. So your network's an extension of that. So when that goes down, you lose servers or you lose applications. We also added the concept of BGP for dynamic routing. Because remember, this network environment now with network virtualization is pretty dynamic in the routes that we can add that can come on board with a no site-to-site gateway. So you don't want anything static where you have to now go configure it and tell the network, hey, I just added another VPN tunnel, you should do something with it. With BGP, that comes online and starts getting into the routing tables and automatically allows you to start to do traffic. Okay. Now, so I talked about a bunch of stuff. I'm going to turn it over to Philip. He's going to tell you how he's actually using some of this stuff to deliver a live service.
Cool. Thanks, Alan. Right, okay. So let's jump forward. Perfect. Okay. So as a service provider, I only care about two things. Actually, I care about three things, but two of them. The first thing is providing a service that meets my customers' needs. Yes, making stuff they want to buy. And while doing that, I need to be able to drive my operational cost right down. IT is my business. And we've got service providers in the room, so we're getting some nodding heads. And therefore, at the end of the day, what I want to do is make money. Yes, I'm not a cost center. I want to earn money. At the end of the day, I like fast cars, and I have a family to feed, so I want to make money. It has a fundamentally different view of the way I want to drive IT services. So what I need to do is I need to design and implement a system that achieves those two things, providing services to meet my customers' needs and driving down my operational cost. So let's just talk about what we do at NTTX. We are a service provider. We specialize in next-generation services. Yes, advanced future-generation services in two key areas. Public cloud, true multi-tenant services, Alan was talking about these earlier, and in the hybrid cloud space, where people are running IaaS services, off-site backup services, some of the other services Alan spoke about earlier. And we're very key on a number of areas when we actually deliver these services. The first thing is we are delivering the highest levels of customer services. We have engineers who understand these services and can deliver superb customer service to our users. We also deliver end-to-end high availability across all of our services. And we deliver geolocation agnostic access, what I call the Facebook syndrome, where it doesn't matter where the user is, they get a consistent user experience. And that's a really important thing to drive forward. And it differentiates us from the rest of our market and allows us to drive forward fantastic services. So let's look at where we were in the 2012 stack. And we've been a service provider now for many years, in fact, since the late 90s. And then Service 2012 came along, and we decided we were going to look at a number of engineering goals that we were going to change. So the first thing, we're going to do 100% virtualization. 100%. Zero on-tin. We were going to do 100% automation. Yes. I have no operation staff at all. We have no staff who use server consoles ever. Yes. Support for diverse workloads, which we'll talk about more in a minute. The ability to actually drive the entire thing on the end-to-end stack. The ability to build everything on the Microsoft stack. Why do I want to do that? Because if I do that, I remove middleware. Right? Why do I want to get rid of middleware? Because I stop paying those middleware vendors money. Who's written Quest or EMC, some lots of big checks? Who likes writing Cisco, nice switch management checks? Yep, nodding heads. Who likes paying the evil Symantec lots of money for services? Nodding heads, right, good. Yes, all those organizations cost me money. Right? I don't want to pay any of them. Right? And the last really key thing we're interested in doing is just-in-time hardware provisioning. What enterprises do is enterprises go and buy $2 million worth of hardware, or 2 million euros as we're in Europe, and it sits there. Sits there for 3-4 years and depreciates like a stone. Right? And after 3 or 4 years' time, you might have actually filled that capacity up and made use of it. We don't do that. What I do is I literally buy disks and blades as we need them. Because we have 100% automation, yes, we can do that, and that's an absolutely key requirement, and that's absolutely key as a service provider. So let's talk about our logical architecture that we built out inside of Service 2012. And Alan's talked about this storage, networking, compute. So how did we literally do it? So the first thing we did, surprisingly enough, is we got rid of the SAN provider, those expensive people, and we implemented storage spaces. Wonderful technology implemented in Service 2012. I'm sure a lot of you have now heard of it. On top of that, we built a scale-out file server. That is a highly available, distributed file delivery platform. And let's just think about that for a second. That's not just a highly available platform. That's a continuously available platform. Yes. Literally, we can pull servers out from that scale-out file server, and the connections, the devices connecting to it, are completely oblivious to it. And the nicest thing about that platform is that I can independently scale it from the rest of the network. I can add nodes to the scale-out file server. I can add storage to the scale-out file server, independently of the rest of the network. So the next thing we do at the networking layer is we use the SMB3 transport layer. Shares. Whack shares, SMB3. Now, why was this so important to us? What I used to do is I used to have expensive switches. I used to do things like VLANs and nasty quals and all these other bits and pieces, and I wrote lots of big checks to Cisco. Now what I do is I use cheap commodity switches. In our case, we use Dell. We use nasty, cheap Dell switches. And I don't mean they're Force 10 stuff. I mean they're nasty Power Connect stuff. Because all I care about is wire speed switches, right, that will drive efficient connectivity. Because I'm doing all my management layer of the network. I'm doing all that network management layer inside the software stack, all on top of Windows. And then at the top, I have this compute. Yes, I have a hypervisor cluster, Hyper-V. Right? But if you notice up here, I've got a number of boxes. So you'll notice the box on the left here, I talk about diverse workloads. So inside of our single hypervisor clusters, we literally pour virtualized workloads. Domain controllers, DNS servers, DNS, DHCP, Link, Exchange, SharePoint, personal desktops, RDSH. All of those workloads are poured into single clusters. Now, that's a really key challenge because if you think about it, the workload of an Exchange server is fundamentally different to the workload of an individual user's personal desktop, a virtual machine. So we need the ability to manage those diverse workloads end-to-end across this system so that we don't get a noisy neighbor problem, that we don't get a user who's got a single virtual machine killing the performance of my large Exchange servers. But we can drive that capability inside the Windows stack using PowerShell and automation and control. No middleware, no VLANs, none of that other rubbish that we always talk about. So let's look at this in practical implementation. So these are our two data centers in the UK. And underneath the covers, their configuration is identical. We are scale-out file server, SMB3 transport, hypervisor clusters. We are then using the capabilities built into Windows and also the capabilities built into the applications themselves to make the application layer, that lovely thing at the top, the virtualization compute fabric, highly available. So think about that for a second. So we've got these high availability clusters, but then we're doing things like using Exchange DAG or SQL clustering to actually make the application level highly available. And that's the key thing. So the end user experience is a highly available system that just works. Because at the end of the day, what we want is a platform that our users use. Our users just want to do real computing. They want stuff that just works. And if it doesn't work, they don't pay us money. And I like getting paid money. So let's talk about some of those architecture choices. So the first thing, of course, we did is we used scale file servers and we used storage spaces. And we were doing it with cheap generic JBOD. In our case, we used Dell, right? And these are just dumb disk enclosures. This gives us continuous availability on the storage space. It also gives us the ability to scale independently. Right? I can scale this platform independently of the rest of my system. And the nice thing about the whole thing, it's really, really cheap. I had a conversation with somebody fairly recently, and I asked them how much it cost them to put 100 terabytes of storage onto a SAN vendor, who will remain nameless. They quoted me about $250,000, about $250,000 to put on 100 terabytes of storage, bring it online. I did the same thing earlier on this year, and it cost me under $60,000 on storage spaces. Now, pardon? Right, that's a very good question. So the question is, do we get the same performance? The key thing is when you look at the end-to-end stack, you are actually getting better performance when you factor in the other components that you're actually driving at the end-to-end stack. Yeah. But the nicest thing about the situation is that I'm running at approximately 20% of my storage costs from what I was running under SAN. And I'm not only running at 20% storage costs, but I'm running a highly available distributed system that I can now scale independently. Oh, and by the way, I haven't written a SAN vendor some large check for their pointless management software. One of the best technologies that came out of Server 2012. Highly, highly recommended. Okay, so this is the next key thing, this middle network layer. Alan was touching on some of these challenges, some of these separation challenges, some of these quals challenges. And the old-fashioned way of doing this was with expensive switches and doing it all at the hardware layer. So what we do instead is we say, let's let Windows do the work. Yes? So I take advantage of the virtualized network teaming built into Windows. I take advantage of the fact that I have quals on the vSwitch. Right? Fantastic capability. The fact that I can manage my VM quals inside of my vSwitches. Yes, huge benefit. And because it's inside of Windows, I can use the same management stack and the same management capability as I use for everything else. And the other huge, huge win of Server 2012 was SMB teaming. Are people familiar with SMB teaming? Oh, good. Quiet faces in the room. So, SMB teaming is a wonderful technology. SMB teaming, or sorry, forgive me, SMB multi-channel, forgive me, I'm getting the wrong name, basically allows SMB to use multiple NICs at once to give bidirectional throughput. Why is this really important? Well, because we've now shifted everything into the software layer, into Windows, and what I want to do, of course, is drive my virtual hard disk over my network, over SMB3. And SMB multi-channel will naturally use all of the NICs I have available inside my hypervisors. That's really important to me because one of the other things I do is I buy the best bang for buck servers I can buy each month. Right? Well, that means that some of my servers have 4 NICs, some of them have 6 NICs, some of them have 8. Beauty of SMB multi-channel and also of doing the management inside the software layer is I don't need to worry about standardization on the hardware. I can deal with the configuration changes and it just works. Absolutely wonderful capabilities. So, the last thing we're going to talk about is we're going to talk about the Hyper-V layer. So, if you remember in one of my early diagrams, I showed you all these various workloads, Link, Exchange, SharePoint, RDSH, all poured inside the hypervisor. So, one of the lovely things I can now do is I can build very, very large Hyper-V clusters, 63, 64 nodes clusters. And that means I can pour literally thousands and thousands of VMs into that single cluster. And these VMs are various sizes. Some of them are small single-user personal desktops. Others are large Exchange mailbox servers. But what's powerful about this is I pour them into the cluster, and then I can let the cluster do the management. I can move them around to allow my hypervisors to be run at that 90% or higher optimization. I can keep enough spare capacity in the network that I can lose nodes, or I can retire nodes when we're doing things like in-place updating. Right? And I can deal with affinity and anti-affinity, all capabilities built into Windows to make sure I don't get a situation where I've got 2 VMs that actually shouldn't be together physically on the same host. Right? All of that capability is just given to me because I can build very large clusters. The second enormous win that came into Hyper-V inside of 2012 was the fact that I can also now build very, very large virtual machines. Yeah. So I can build virtual machines that are sort of bigger than most of the physical machines you can actually buy, which means I can run very powerful workloads. When I have the clients who come along and say, well, actually, Philip, what I want to do is drive a very large SQL database. And I'm happily going to pay you £1,000 a month for the pleasure, but I need to guarantee that. I can pour that workload into this same cluster, and with some of the other technologies, actually guarantee that works. So let's just think about that for a second. We have, I'll come to demo in a second. Let's just think about what we've done there for a second. We have a situation where I've managed to do radical simplification of my network. I've cut out middleware, and I've built a large compute fabric that I can pour workloads into with 100% automation and 100% high availability while driving down costs for things I care about as a service provider. So what's interesting now is let's actually talk about what that means in the real world. So what I'm going to do is do a quick demo. Hopefully it's going to come up. It is. Good. Okay. So here we have a VM, virtual machine. This is a personal desktop. People familiar with personal desktops? Remoting into a personal desktop? Right. So just be very clear. This actually is a live machine. This isn't a demo. This is going back to the UK. In fact, this is my personal desktop. This is running on top of all the capabilities I just spoke about. Storage spaces, scale-out file server, SMB3, Hyper-V cluster. Inside of that is running a virtual machine, but is then having all of the remote desktop services experience on top of it, all running as virtual machines, and then being pumped out over the internet down here to Madrid. Okay, so that's what's going on here. This isn't some internal demo. So the first thing you'll notice, of course, is I can do all the normal things. Let's bring up good old Word. There we are. And I can type, and I'm sure you're all very happy seeing this sort of thing going on. There we are. There's Word. But also, I spoke about all these other services. So, there is, here is also my Outlook. Oh, you can see my wife wants a lion. Clearly, after looking after my young son for the last goodness knows however, she clearly wants a lion. So, you can see here, there is Outlook running perfectly well. That is being served off of the Exchange servers. Let's just minimize that. Good. Now, other things here, you can see my SharePoint. So far, what have I shown you? I've shown you a VM running on top of the stack, and I've also shown you my Outlook, which is backing off to a full Exchange implementation, and there's my SharePoint implementation. Right? This is all being fed out of that single unified fabric. Let's do something else. Let's go over here, and let's see if one of my colleagues is around. He might be. Let's see if he's awake. Let's see if he wants to do some whiteboarding. Let's see if he's around. So let's look at this as a thing. So I'm now inside of a virtual desktop. Hold on. I'm doing real-time drawing. So this is a VM that I'm doing real-time animation drawing on, running over the internet, backed with a 100% virtualized stack, running 100% on the Windows stack. This just wasn't possible in previous generations. Let's do something else. Let's go over here, and let's do that. So again, there we are. This is video running inside of a VM, again, over the internet, on that stack, running perfectly well. The beauty of this is a service that users just take. The focus here is that users are just taking services they want to buy and consume. Let's pause that. And we'll do one last thing, just to entertain people. So, is anyone familiar with the Haven, the DX11 demo? People ever seen this? So, this is a DirectX 11 demo. Right, it's designed for stressing graphics cards. Designed to actually kill them. So, let's go and start moving around, shall we? So, hold on. Let's think what's going on there. You see what's going on here? So, as you can see, this is real-time rendering. This is real-time 3D rendering, yes, running on a VM, on that stack I spoke about, being delivered over the internet. So I now have customers who are 3D CAD CAM customers who come to me and they run their 3D CAD CAM out of this sort of technology. Right? And I can charge them a very large premium for the pleasure. Right? So all of that theoretical stack that Alan spoke about, this is being delivered as real end-user custom services. And I stress again, this is not a demo I've got pre-canned in here. This is my live system going back to the UK. So I'm going halfway across Europe to do that. That is a very compelling statement of the quality of the technology Microsoft delivered inside the Surface 2012. So, with that done, let's switch back. We're done with it. So, now let's talk about R2. How are we doing for time? I've got 8 minutes. Okay. So, R2 is a very, very, very interesting release from Microsoft because I call it the all the stuff 2012 didn't quite get finished release. And I'm very excited about it because we get 3 main benefits. We get performance and scale, we get cost reduction, and we get service improvements. Hold on. That means Microsoft's delivering all of those things that actually I really care about. Cost reduction, performance, service. All the things I care about. Alan touched on the fact that Microsoft is now caring about what service providers need. Yes, they really are now delivering, and in some ways, this thinking, making everyone think as if they're a service provider, even if you're enterprise, is a really key change. So let's talk about some of those technologies first of all. There is a talk coming on actually after this session, which I'd highly recommend going to, which in fact is being delivered by Brian at the front here, about storage space and some of the changes in R2. You may or may not be aware that we've now got full tiering capabilities inside of spaces inside of R2, and we've got full dedupe capabilities. Right? Now you might sit there and go, hold on, why is that good? Why is that useful? Okay. Well, that's why. Think about that a second. 80% storage reduction for VDI workloads. Yes? 80%. So I'm having to buy considerably less storage disks than I used to. Yes? That is a huge benefit. Let's look at it the other way. When I did this under Service 2012, yes, 1,000 personal desktops was costing me 40 terabytes. So it's costing me 40 gig of VM. Yep, 1,000 of them, 40 terabytes. Yes, it's now going to cost me 8. That saving alone has dropped over £3 off my per user hosting cost for a personal desktop a month. Per user. You do the mathematics. And I'm still being able to charge the same level of service. This one capability of loan makes R2 worth it. Let's talk about the next most interesting thing. So I'm sure people in here are familiar with CSV. The Scale-Up File Server team have made some great changes to the way Scale-Up File Server works. And critically, what they've done is they have mitigated many of the requirements for redirection. So you don't need the CSV network, because what now happens is that the incoming SMB connection is actually redirected over to the node that owns the storage. Yes? That has considerable performance improvements and considerable reduction. What it now means is I don't need to run a dedicated CSV network. Remember, I'm about simplification, I'm about standardization. And actually, that resource I have today in my CSV network, I'm now just throwing into my pool of networking capability for my SMB3 workloads and have my VMs talking. Yes? Simplification, getting rid of this complexity, much simpler, fantastic technology. Wake up. Have we moved? There we are, good. Right. And then the last thing, my two favorite things. Alan touched on the first one of these. So Gen 2 VMs. Is anyone familiar with the dreaded legacy NIC problem when you want to do remote boot, when you want to do Windows deployment services? Yes, some nodding heads in here. So with Gen 2 VMs, we finally get rid of the legacy NIC requirement. I can do Windows deployment services, absolutely key for doing automated VM build-out, yes, and I can now finally do it without legacy NIC. Yes, so Gen 2 VMs are huge. And my favorite one of the whole lot is VHDX-based guest clusters. We have a lot of customers who come to us and say, I want to have that nasty line of business application hosted in a cluster, a virtualized cluster. What I had to do under 2012 was I had to actually run a completely separate iSCSI fabric so that I could pump iSCSI up. I'm seeing some nodding heads, and people have been put through this pain. So I could run some iSCSI fabric up into those VMs. It's the only reason I had to maintain iSCSI, which was bonkers. I was maintaining iSCSI just to do VM guests. With shared VHDX, I can finally do the shared VHDX, and I can do the whole thing over SMB3. So I have a unified fabric, and finally iSCSI can go and die and crawl off the mortal coil. And trust me, I despise iSCSI with a passion. Right, and the last wonderful thing, of course, is the live migration capabilities. So unfortunately, we still can't have mixed versions of Windows inside of clusters. But because we can do live migration between 2012 and 2012 R2, we can do that migration without downtime. Yes, which is, Alan was touching on. For me, downtime means no money, and I don't like no money. And this is the other key thing to think about as a service provider. As an enterprise, downtime means grumpy users, but the users don't leave because they work for you. Downtime for me means grumpy user doesn't pay me, user goes somewhere else. User goes somewhere else makes me really, really unhappy.
In enterprise, it just means somebody loses their job eventually. It's the same effect, right?
Yeah, exactly.
Yeah.
Yes, exactly. Yes.
Nothing good comes of it.
Not good at all, yes. So those changes alone are a huge benefit in the R2 space. So now let's talk about that service capability. So I've already shown you some of the fantastic experiences inside the remote desktop and some of those other services I was running, and they were seriously good. But we have the RDS team in particular, and I thought I'd bring the RDS stuff out briefly. They have really improved remote app experience. So we've now got a file. Has anyone used a remote app in here? Some nodding heads. Yes, good. So we've got some nodding heads. So remote app isn't very pleasant today when it gets a disconnection because you get a nasty dialog box and it's all a bit ugly. So they've really improved that experience. When there's a disconnection or a pause or you get problems, it's a much more graceful experience to the user. That change is fantastic because it just makes my user experience better. And it's a much easier thing for me to sell to. And we also have performance improvements inside of the virtual GPU and the scale enhancements. That lovely 3D real-time demo I was doing, that real-time rendering, that stuff's got even better under R2 on the same hardware. Fantastic capabilities. And then the last thing I'm going to talk about is the big changes and the big investments Microsoft's made in hybrid cloud. Now, hybrid cloud is important because it's a way of the service provider entering the enterprise space. Yes. It's very hard for me as a service provider to go, hello, Mr. Enterprise with 10,000 users. I want you to go and move your entire Exchange infrastructure over to me tomorrow. But just don't do it. It's a tough sell. Hybrid cloud is a wonderful way for us to actually go to those companies and say, let's do some stuff. Let's put some services with us and pay me some money, which is really good. And over time, you can put more services with me. Great entry-level services. So Alan's touched on the multi-tenant RAS gateway. Very, very, very powerful capability. In reality, it makes the network virtualization stack usable under 2012 R2. Wonderful capability. Did a lot of testing with it recently. We've then got the storage as a service capabilities. So I can now actually create virtual external hard disks, and I can actually provide storage to on-prem situations as a service. Wonderful capability. VM usage builds we've touched on. But the last one I really want to talk about are BYOD, bring your own device, which is a huge requirement nowadays. And actually being able to do that BYOD device management as a service, allowing me not only to be able to go and manage devices that I have with my clients, but actually provide BYOD as a service to the enterprise for their internal users. Huge growth space, and very difficult for the enterprise customers to bring on themselves. Right? And we can go there, we can drive it as a service. And the last one Alan touched on, which is the DR as a service capability. Integrating that on-prem to service provider or that on-prem to remote on-prem to service provider scenario. Allowing us to actually get into that cycle as a service provider and drive revenue from it. Yeah. And the best thing about R2, and particularly in the System Sense 2012 R2 capabilities, is that these things have been delivered as a turnkey service so that service providers can actually just light them up very easily. Yeah, not a huge amount of engineering time. They're just there and they just work. And in fact, some of the people who own those technologies are actually in the rooms. If you're interested in them, have a conversation with them. So I have 21 seconds left, which is good timing. So shall we wrap up?
Yes. So one thing that I want to make very clear, right? So you hear this concept of service provider. Remember in the beginning, the service provider principle is everybody is a service provider. Everyone in this room is a service provider, period. That means all these principles apply to you, or they will apply to you. If you don't think they apply to you, they're going to apply to you soon. Your boss is going to come into your office and say, we're a service provider here. We're going to start building stuff out as a service provider. We're going to host applications as service providers. We're going to go to our business units and say, we're a service provider offering you great levels of service. Now build out this infrastructure for me. Or you're already in some level of doing it. You have a lot of virtualization. Now you're moving into what I call the cloudification stage of your virtual environment. We have 8,000 VMs. Do I have a cloud? Not yet. We're working on that. Now, generally, self-service, building stuff out as a service comes down to it. So all these principles apply. So we may talk service provider. Everyone here is a service provider. And the quicker you start thinking that way, the better it is for you. Who here doesn't want to work on building out a service? Because like I said in the beginning, your job and role over the next 5 to 15 years, we're all going to be working on services in some mechanism or fashion. Whether you're operating it, building it, deploying it, building an app on it, you're going to be working on a service. Right? So this is a great opportunity to start thinking about the kinds of problems that building out services brings along with it. There's problems, right? There's some different problems than you deal with in the past when you were on a single server, single app, or even just throwing virtual machines around. Right? So this is an opportunity. And the other thing I want you to think about is from here on out, every time you see me, you should think, hey, these guys added a new service in Windows, whatever the next version is. Oh, I see how that goes to help me building out that service. Look at anything virtualization and say, where's that fit in the service? Does it fit storage, compute, networking, automation, management? I want you to think about that. And if you ever see something in the box that you say, that has nothing to do with a service, I want you to grab me and tell me. And I'll tell you, everything's going to be focused on that service.
Actually, and joking aside, I've been doing this to Alan for years, and it does actually come out. It does actually get delivered, and I think that's a worthwhile point to take away. If you raise this stuff, it will get there, and that's a really important thing to bring out.
Good. So, anybody have any questions? Hopefully, this has been very valuable. We covered a lot of stuff. We didn't cover a whole much. We could have spent all day in this room covering this stuff. But anybody have any questions? Yes.
We do have Hyper-V.
Repeat the question.
Sorry, forgive me. So the question was, do we use Hyper-V Replica? So we do use Hyper-V Replica as part of the platform for certain capabilities, yes. So we do a combination of Hyper-V Replica for certain scenarios, and we also use application HA, things like DAG built into Exchange, or high availability built into SQL for other services. Sorry, go ahead.
Follow-up question from that. How do you do DR for your guest clusters that you should be...
Okay, so the question is, can you do DR for guest clusters? The simple answer is you can't use Hyper-V Replica with guest clusters. Right? So what you need to do is then application level HA, and it depends on the application to do it. Right? But the follow-up question for that would be, can you do geographically separated clusters? And it is not a supported solution for Microsoft, is the basic answer for that situation. Yes. DR, but in reality, if you think about it, DR for clusters, would you really want to do Hyper-V Replica for DR for cluster? Might be one best one to take offline because there are some interesting challenges there. Go for it. There's another gentleman.
How does your backup architecture look in a nutshell?
Okay, so for backup, we use Data Protection Manager. But this is a very good point because actually Data Protection Manager for us is actually virtualized. Right? And in fact, the actual backups are going into VHDXs. No, we have, so the only customers we have who need tapes are people for compliant reasons who need to go back into worm drives. And so we do have some worm drives for specific customers. Yeah, and that we just have them, yes. Yeah, but generally I've given up on tape because it's slow, it's expensive, it doesn't, yes. So it's specifically the worm drives, the stuff we have in place. Yes. Anything else?
Excellent.
Good.
Thanks for your time. Thank you.
Thank you.